So today in physics we will do force and pressure. Within that we will do turning effect of the force. So before doing that, I want to tell you that what is the force. You know that when a body does not change its position with respect to the surrounding, we call it that it is in the rest. And when the body changes its position with respect to its surrounding, then that is known as its motion. Now, what is a force? The force is a cause which tends to result in movement or change in size or shape of the body. It means whenever a force is applied, then the body, if it is rest, it will start moving, or when a force is applied, then a body, when it is motion, it can come to rest or maybe speed up, or maybe its direction will change. And sometimes due to the application of force, the shape and the size of the body changes. For example, suppose a grass roller initially at rest, but when a force is applied, then it will start moving. So due to the application of force, here this is an example where a body which was initially at rest starts moving due to application of force. Now for example, second example, when a fielder catches a ball, then the ball stops moving. So this is the second example where due to the application of force, when the force is applied, the body come to rest. Third is that when brake is applied, at that time a car which is moving with a high speed then slows down. So force is responsible for the change in speed. Then whenever we push the swing, a girl swinging, then its speed up. So speed can change here, and whenever a player when applies force by hockey stick on the ball, the direction of motion of the ball changes. And when the force is applied, then you can stretch or squeeze a body. And if it is not free to move, then its size or shape may changes. For example, when a rubber is stretched, then its length increases, and when you squeeze a tube of gum, then its shape changes. Thus, what is a force? It means a force which changes the state of rest or of motion of a body, or changes the size or the shape of the body. Now next one is the unit of the force. Unit of the force, SI unit of the force is unit of the force, the SI unit of force is equal to Newton. And what is this Newton? Newton, when a force of, what is Newton? When a body of 1 kilogram accelerate with 1 meter per second square, then that one is known as 1 Newton of force. So 1 Newton is defined as a force which when applied on a moving body of mass 1 kilogram in the direction of its motion and increases its speed by 1 meter in 1 second. So that is known as 1 meter. Other unit of this force is dyne, and 1 kilogram force or 1 gram force. 1 kilogram force is the force with which the earth attracts 1 kilogram of body towards itself, and 1 kilogram force is equal to 10 Newton. 1 kilogram force is equal to 10 Newton. That means Newton is a force that we have to exert to hold a mass of 100 gram on our palm. Now next I will discuss about the turning effect of a force. Whenever the force is applied on a rigid body, whenever a body is rigid and when acted upon by a force, then it has two types of motion. One is the when force acts on a stationary rigid body which is free to move. Suppose this is a body, suppose this is a ball, and now it is on this surface and it is free to move. So if when force is applied, it is free. So when force is applied, suppose here, then what will happen? It will move in this direction. It will move in this direction in a straight line, and that motion is known as the linear or translational motion. So when a force is when force acts on a stationary rigid body which is free to move, the body starts moving in a straight path in the direction of force, and this motion is, due to this, whatever the motion is produced, that will be the linear or the translational motion. But suppose the same body is there and it is fixed here, it is rigid, the rigid body, and here it is fixed. This fixed point is known as the pivot, and when this force is applied, then this body will start rotating. It means a turning effect is produced due to the applied force when a body is fixed at a particular point. This point is known as the pivot, and this effect of force, the turning effect of the force, is known as the moment. So what is moment? Moment is the turning effect produced within the body when it is fixed at a particular point, that is a point which is known as the pivot. So when it is fixed and when the force is applied, then it will start rotating. So turning effect is produced, and this is known as the moment. So due to the moment or due to turning effect of the force, what type of motion is produced within the body? That is the rotational. That is rotational motion. So if the body is fixed, then whenever the force is applied, and due to this turning effect of force or the moment, the body, within the body, rotational movement or rotational motion is produced. But when body is free to move, when body is rigid but it is free to move, and when force is applied, at that time within the body, what type of motion is produced? That is the linear or the transitional motion is produced. Okay. Now next one is, this is the turning effect of the force. Now next is, have you observed that this force is actually depends on two factors. The turning effect of the force or the moment of the force depends on two factors. What are those two factors? First is it depends on the magnitude of the force applied, and then second, it depends on the perpendicular distance of the force applied from the pivoted point. So it depends on how much force. Suppose this force F force is applied, and the perpendicular distance, this force, whatever the force is applied, its distance from this, the perpendicular distance, this is the line of action, so this distance, this much distance, so D. So that is equal to what? That is equal to the moment of force or turning effect of the force. Now the unit of this moment of force is equal to, we know that the unit of force is what? Newton, and the SI unit of distance is meter. So the unit of moment of the force, moment of the force, that is equal to Newton meter, equal to Newton meter. Okay. So this is Newton meter. It means it depends on two factors, force applied and the distance. More the force, more will be the moment or turning effect of the force will be there, and more the perpendicular distance of the force applied from the pivoted point. The more the distance, more will be the turning effect. For example, you have noticed that whenever you open or shut a door, you have to apply the force. Now since you are applying the force at various position within the door, suppose you are applying the force at the edge, from the edge of the door, then easily you can open or close the door. But if you want to close or open the door and you are applying the force somewhere middle, or at the center, nearby the edge. As you move towards the nearby the edge, you will require more force to close or open the door. And now if you apply the force by putting your hand on the hinge, then you will observe that it's not possible to open or close the door. So suppose this is the door, okay, and here is the hinge. Hinges are there. Now if you are applying the force at this place, from this point easily you can open or close the door. You can open or close the door. But when you apply the force at this point, suppose your hand is here, then you require more force to open or close the door. And when you will apply the force at this point, it's not possible for you to open or close the door. It means turning effect depends on what? Same force you are applying at, you are applying here, suppose here the distance is D. The distance is D and you are applying the force F. Then here your moment of force will be equal to F into D. But when you are putting your hand here, your hand is here, and if you are applying the force at that time, you require 2F into half D. The turning effect of the force, for that you will require twice the force and the distance will be half. So it means it depends on two factors, first on the force and second on the perpendicular distance of the applied force from the pivoted point. The same thing you will observe when the turning effect in case of a hand floor grinder. In the case of hand floor grinder, you will observe that at the rim of the grinder a handle is there. At the rim a handle is provided, and by turning this with the help of this handle, it is rotated so that the floor is grinded. If that handle is suppose nearby the pivot, then it's very difficult to rotate. You have to apply more force to rotate that one. Other examples are that spanner. Spanner used to tighten or loosen a nut. Has a long handle to produce a large turning effect by a small force applied at the end of its handle. If the handle of the spanner length is too much, then easily you can tighten or loosen a nut. But if handle is smaller, then it's very difficult to tighten, because at that time you have to apply more force. So what you have concluded from this, from the above all these examples, that is the opening or closing of the gate, that is door, and this one spanner, or this floor grinder, hand floor grinder, all these examples indicates that the turning effect of a body about a pivot depends not only on the magnitude of the applied force, but it also depends on the perpendicular distance of the force from the point of rotation. So moment of force is equal to what? The product of magnitude of the force and the distance, and the perpendicular distance of the force from the pivoted point. Now next we will discuss about what is a couple. What is a couple? Suppose this is a tabletop, or tabletop is there, and one of you are applying the force from this side, another boy is also applying the force from this side, equal but opposite force, and the line of action of this force, this is the line of action of this force, that is the same. Then what you will notice that this tabletop will be at the same position, no change is observed. But if the same tabletop is there and the same two boys are there applying equal force, one is applying here, another at this place, equal and opposite forces are applied on the tabletop, equal opposite parallel forces are applied on this tabletop, but their line of action is not same. The line of action for this force is this one, and the line of action for this force is this one. Since the line of action is not same, so due to this force, this tabletop will move in this direction, and due to this turning effect, it will move in this, and it is fixed here. So this will move in this direction. So due to these two equal and opposite forces, but their line of action is not same, the turning effect is produced, or rotation. This tabletop will rotate, and this is what this forms the couple. So what is the couple? Couple, when two equal and opposite forces of same magnitude applied on the same article, but their line of action is not same, then they will form the couple. That is known as the couple. Now next is that we will discuss few sums related to this turning effect of the force. Turning effect of the force, we will discuss few sums related to the turning effect of the force. For example, a door is there. This is a door. Okay. A force of suppose 6 Newton is applied at a distance of 10 meter from the hinge. At a perpendicular distance of 10 meter from the hinge. Then what is the moment of force produced, or what is the turning effect of produced in this case? So here the force F is equal to 6 Newton, and your distance, the perpendicular distance, is your 10 meter. So the moment of force or moment will be equal to F into D. So that is equal to 6 Newton into 10 meter. So that is equal to 60 Newton meter. So in this way we can find out the magnitude of the moment of the force. Next is, suppose it is given that what is the perpendicular distance between the force and turning point if the force of 25 Newton produces a moment of force of 12.5 Newton meter. So here force is equal to 25 Newton and the moment of force is equal to 12.5 Newton meter. This is what moment of force. And asking you about the perpendicular, the distance from where the force has been applied. So I know that moment of force is equal to F into D. Now this value is given to you 12.5 Newton meter. So that is equal to your force is 25 Newton, you write it here, into distance you have to calculate. So D is equal to 12.5 divided by 25 Newton meter and Newton. So that is equal to, this will be cancelled to, so 0.5 meter or 0.5 meter, that is equal to 50 centimeter. So at a distance of 50 centimeter, the 25 Newton of force is applied, then a moment of the force produced will be 12.5 Newton meter. So this is all about the turning effect of the force.